now proceed to the second example. Okay. Here we use the trigonometric identity or trigonometric identities in rewriting an expression in terms of sine and cosine. Okay. In this case, the trigonometric identities will be useful in writing a complicated expression into a simpler expression, right? And here it suggests that we're going to use or express them in terms of sine and cosine. So let's see what will happen if we will write 1 plus cosine squared theta over 1 minus cosine squared theta in terms of sine and cosine. So let me demonstrate that. So I have 1 plus cotangent squared theta over 1 minus cosecant squared theta. Okay. So what we will do here is to make use of the quotient identity, no? For cotangent, because you recall that, okay, from the list of identities we have, that cotangent theta is actually cosine theta over sine theta. So we replace this cotangent with cosine theta over sine theta, then square. And then we have cosecant squared theta. We recall also that cosecant theta from reciprocal identities, right? This is the reciprocal of sine. So therefore, this is 1 over sine theta. So we replace that cosecant with 1 over sine theta, then square. Then we continue simplifying. Of course, you have here 1 plus cosine squared theta over sine squared theta, then over 1 minus 1 over sine squared theta. And then the numerator, we'll combine that as a single fraction. So we take sine squared theta as the common denominator. And for 1 here, this will become sine squared theta, then plus cosine squared theta. And in the denominator, we'll take sine squared theta as the common denominator. And then 1 here will become sine squared theta, then minus 1. Okay? If you look at sine squared theta plus cosine squared theta, there is an identity. We call that Pythagorean identity that says sine squared theta plus cosine squared theta is equal to 1, right? So remember that. We will replace, therefore, sine squared theta plus cosine squared theta with 1. Then you have 1 over sine squared theta. And then at the same time, we're going to get the reciprocal of this, because according to one of the properties in algebra, right? You have A over B over C over D. This is just the same as the product of A over B, and then the reciprocal of C over D, which is D over C. So we'll apply that. Okay, 1 over sine squared theta, then the reciprocal of sine squared theta minus 1 over sine squared theta is sine squared theta over sine squared theta minus 1. And obviously here we cancel sine squared theta, sine squared theta. So you're left with 1 over sine squared theta minus 1. Now, look at sine squared theta minus 1. One of the expressions that we can derive from this identity here is that you can express this as cosine squared theta is equal to 1 minus sine squared theta, right? But this is sine squared theta minus 1 instead of 1 minus sine squared theta. So what do we do? Well, again, there's a property in algebra that says a minus b, you can take out negative there, right? And therefore, a will become negative a, and negative b will become positive b, because if you multiply back the negative there, it will go back to a minus b. But negative a plus b can be written as b minus a. And this is the same with sine squared theta minus 1. This can be written as 1 over 1 minus sine squared theta. But what is 1 minus sine squared theta? So from this identity, that's equal to cosine squared theta, 1 over cosine squared theta. Negative, okay? 1 over negative cosine squared theta. Negative due to this one, right? And therefore, this is equal to negative. What is 1 over cosine? 1 over cosine, according to the reciprocal identity, the reciprocal of cosine is secant. Yeah? Secant theta equals 1 over cosine theta. So 1 over cosine squared theta is actually negative secant squared theta. And this is the simplest form, no, of the original expression 1 plus cotangent squared theta over 1 minus cosecant squared theta, right? Okay. Again, I will some of the examples here will be left as an exercise later for your discussion among yourselves. But let me check on example number 3 next. Because in example number 3, we're considering the next use of trigonometric identity, and that is on verifying an identity, which is which does not belong to the fundamental identities, of course, right? Actually, succeeding identities will be verified to be true, no, by using this technique that we're going to demonstrate in this example. And how do you verify an identity? Well, we have here some of the suggestions or hints on how you verify identities. Of course, you have to learn first the fundamental identities. It's very important. Familiarizing with the fundamental identities is very important, no, to be successful in verifying an identity. And then after that, you choose which side is more complicated and then work on that one, okay? Or rewrite the more complicated side into a simpler form. Then apply properties. Your objective is to convert that into an expression equivalent to the side that is not complicated, right? And so on and so forth. No? So let's check on this one for this particular example. Of course, between cotangent theta plus 1 and cosecant theta, cosine theta plus sine theta, cosecant theta, the left-hand side or the right-hand side is more complicated than the left-hand side, right? So I'm going to start from here, okay? And how do we simplify this? Well, we can multiply first cosecant theta and cosine theta plus sine cosecant theta to cosine theta plus sine theta. At the same time, you can write cosecant theta using the reciprocal identity as 1 over sine theta, right? And then you have cosine theta plus sine theta. And then upon multiplying, you will get cosine theta over sine theta plus sine theta over sine theta. And cosine theta over sine theta is what? Using the quotient identity, no? That's equivalent to cotangent theta, and then this is equal to 1. Now, take note that this is the same as the left-hand side. So you were able to verify the identity. Starting from the more complicated part or side of the equation, we're able to convert that into the expression similar to the other side of the identity, right? So that ends our, usually we use the term proof, no, for the identity.